Laplace transform part 2. Poles and zeros. So please consider a system transfer function that have Hs is equal to Ps over Qs. So poles are the roots of the denominator polynomial. So the one bottom here would be the poles. And then the zeros are roots of the numerator polynomial, which is on top. So poles and zeros specify the set of complex frequency for which the eigenvalue response is infinite or zero respectively. So poles are usually drawn by using x, while zeros is drawn by using 0. So the poles and zeros can occur anywhere in the S-plane. So whenever the poles and zeros are the roots of polynomial with real coefficient, so the poles and zero of the real axis will always occur in complex conjugate pairs, meaning that you will have plus j or minus j. So there can be more than one pole or zero at the same location. And it is also possible to reconstruct your Hs if you are given the graph of a pole zero plot. Another thing is that you have to know when you want to know the order of the system, you just have to see the number of poles. ROC, region of convergence or region of existence. So it is the set of values of S for which the Laplace transform integral can be evaluated. So there are several rules that can be used to quickly determine the ROC without performing any integration. So you don't have to go through integration. You just have to know what is the type of signal and also the location of the pole, the x. So a pole is defined as a value of S that causes the denominator of the transform to become 0. So this is the graph of the ROC, an example. So you have j omega on the y-axis and also the sigma. The region of convergence is over here. So you have the sigma c. So convergence would start from here onwards. Okay, there are 4 types of signals that you have to know. So if you have something like this where it starts somewhere, you have a finite point and it ends at minus infinity, so that would be left-sided signal. If it starts somewhere at one finite point over here and ends at positive infinity, that will be right-sided signal. If it starts at minus infinity and then ends at positive infinity, that will be two-sided. And if it starts somewhere finite and then ends somewhere which is also finite, so that would be finite duration signal. So the rules of the ROC. So if xt is right-sided, then ROC is right-sided. If xt is left-sided, then ROC is left-sided. If xt is two-sided or the sum of a left and right-sided signal, then ROC could either be first a strip or else the individual ROC will not overlap, meaning that it will produce a null set, no signal. If xt is finite duration, then the ROC is the entire S-plane. So you have here the right-sided signal. So starting from here, so this is your sigma c. So sigma c will start from here and then to the right. ROC is always to the right of the S-plane. So your sigma is more than your alpha. And then this would be your left-sided signal. So you have ROC is always to the left of S-plane. You start from here, that will be your sigma c. So your sigma is less than minus alpha. And finally, you have the two-sided signal, where it starts from minus alpha and then ends at alpha. Okay, so your sigma would be between minus alpha to alpha. Okay, this is inverse Laplace transform. So you know how to use Laplace transform, where you change your xt to ss, change from time domain into frequency domain. Now we want to recover back from frequency domain to time domain. So you have seen before how to do it. What we do is we integrate. So this is an equation, st is equal to 1 over 2 pi j, and then the integration of ss est ds from c minus j infinity up until c plus j infinity. So it is quite troublesome to do this. So what we have to do is, instead of using the formula, we're going to apply PFE, which is partial fraction expansion. So how to do that? First, you have to decompose Fs into simple terms by using PFE. And then second, find the inverse of each term by matching entries in the table that have been provided to you. So first, use PFE, and then you refer to the table. So let us see the first examples. Find the inverse Laplace transform of, so you have Fs, so that is in frequency domain. You have 3 over s minus 5 over s plus 1 plus 6 over s squared plus 4. So how to do this? The first step is you have to break it into partial fraction expansion. So you have ft is equal to the inverse Laplace of fs. So that would be the inverse Laplace of 3 over s minus the inverse Laplace of 5 over s plus 1 plus the inverse Laplace of 6 over s squared plus 4. So you have performed the PFE. Now we are going to refer the table. So here, when you have 3 over s, refer to the table. So here you have 1 over s will give you the step function, which is ut. So 3 over s will be 3 ut. So that's why you have 3 ut over here. And then you have 5 over s plus 1. So please refer to the table. 5 over s plus 1 would be this one. Okay. This is the closest. So you have 1 over s minus lambda is equal to exponent lambda t ut. So 5 over s plus 1, that will be 5 exponent minus t. That's why you have it here, 5 exponent minus t. And finally, you have 6 over s squared plus 4. So please refer to the table. So here you have b over s squared plus b squared. So here that would be 3 sine 2t ut based on this one. So that's why you have here 3 sine 2t ut. So that will give you the inverse Laplace transform for the given equation. Let us try another example. So find ft given that fs is equal to s squared plus 12 over s times s plus 2 times s plus 3. Okay. So here we are going to break it with PFE. So you have a over s, and then plus bs plus 2 plus cs plus 3. So first, find out what a is. So you have a is equal to sfs when s is equal to 0. That will give you the equation of s squared plus 12 over s plus 2 times s plus 3, given that your s is equal to 0. So just plug in s is equal to 0 into the equation and you will get a is equal to 2. Next, find out what b is. So b is s plus 2 times your fs, given that your s is equal to minus 2. So you have s squared plus 12 over s times s plus 3 when your s is equal to minus 2. So just plug in s is equal to minus 2 into your s, and that will give you minus 8 for b. And finally, find out what your c is. So you have s plus 3, because the denominator is s plus 3 for c. So you have s is equal to minus 3. So this will give you s squared plus 12 over s times s plus 2 when your s is equal to minus 3. Plug in minus 3 into your s and you will get 7.